This is Olaf again. I want to now start introducing the different input GUIs for MCQSim. As I had mentioned in the previous video, we have here for the input 3 different versions to create fault geometries and to mesh them. In order to run MCQSim, you would have to use only one of them. So you could, for example, define your fault geometries using this A1 GUI and then jump to B and then to C and so forth. Or you could use the GUI A2 and then jump to B and C and so forth. The idea with these GUIs 1, 2, and 3 here is that you have different levels of control of how you define the geometry. So that means, for example, here for the A1 digitize faults GUI, what you will do is actually go take a base map and then start digitizing the fault by hand. Whereas for the other GUI here, you can then enter the fault by hand, essentially defining the length, the width, strike dip, and so forth in this A2 GUI. And for the A3 GUI, what you can do is, if you already have a meshed fault geometry and want to specify other things later on, for example, then strength parameters. So if you have an existing geometry in form of an STL file, you can use that and import it using this GUI. So now with the first video here about input GUIs, I will talk about A1 and how to use it. So in order to do this, let's jump into MATLAB. So right here you can see MATLAB already being open, and here are the different GUIs and some other things lying around. So in order to start this first GUI, we just type A1, essentially the full name. I just tabbed to complete the name as it was found here, just entering, and the GUI will show up. So there's different components to this. First, up here is the part where you will load the fault map, plot the the fault map. By that I mean a base map that contains the trace of the fault that you want to digitize. You have to then specify, or you have to reference the map in some way, as you will see, and then you can start tracing the fault. Here on the other hand, also on the right hand side, you can also specify the position and size and orientation of the boundary faults. Please refer to the papers if you want to know more about this. So in order to start, let's go into this. A first step would be when you want to use this A1 GUI to load a fault map. So you press this button here, and a directory will show up in which you can then go to the file, in this case an image file that contains your base map. I already put it in the same folder, so it was found right here. It's East Anatolian fault. It's a referenced map, so I can just select it and open it. If it was successful, you will see that now this button turns green and I can plot this map. Now that I've plotted it, I can increase the view, and this map is already referenced, at least in a crude way. What you can see here is actually latitude longitudes first, and then my crude, let's say, referencing, where you can see these lines, like 0 here, 400 here, and another 0 here, 400 here. So that means this is kilometers, so we go from 0 to 400 kilometers from here to here. This is our, for example, the east-west extension, and then we have north-south also here. So what we can do then is go into the GUI and specify the maximum northing and minimum northing, and also the same for the easting. Note that even though it says maximum and minimum, this is not supposed to be actually a limiting factor. That means even though we have 0 here and we specify this as the minimum, in that case easting, we can still have values here. We can still use this. The whole point of using these numbers is to reference the image. So the way this works now is that I have defined what the maximum northing is, so this higher, let's say, value for the northing, and I can then click on this button, which allows me to use the G input and then specify at which, in this way, top down or up position this maximum northing is, and I can see it here in this line, so I will click it here. Since this is only for northing, only the for the referencing part, only the up down component, let's say the Y component of this coordinate is actually used. I just pressed the mouse button once and this value is now fixed. That's why it's gray. So we can do the same for the minimum northing. So I press this button again and then specify the 0 in that case. And I do the same here for the easting. Overall, what I'm trying to do is putting these values, these max-min values, really far out, if possible, to extend across the whole image or map. And the reason for this is just to minimize the overall error that could come in from this this referencing approach, which is, it's not perfect, but it's, it serves the purpose actually quite well. Okay, so now this image is referenced. So what we can do now is start digitizing. And for this, I will, as you can see here, go to this next sub window, let's say, or portions of the GUI. And now this element here turns green. Says trace the top of the fault trace. Tracing itself, as you can see here, is left mouse click adds a point, right mouse click deletes a point, and space stops tracing. When you trace, that trace itself gets some properties assigned to it right away. One of them being the name of the fault that you trace right here, as well as a width and a dip angle. And this follows the right hand rule. So let's say I will, in this case, take the values you already see here and start tracing. And I give this the name fault, let's say rupture. I'll just keep the name for now. It's fine. Okay, so in that case, I can just press this button and I will come back into this map here and see my cursor again. And I can, for example, then trace this fault. Meaning, as it said, left mouse button adding a point, and so forth. I'm not trying to be very precise here right now, just to try to get the image across, or the whole concept across. If you think that you made a mistake by accidentally, pressing the wrong position, just again take the right button and remove these points, and then you can continue. And if you press space, then you have traced this part, and you already have this section is done. Let's say, yes. Maybe you want to say, okay, actually I want to zoom in, or I want to continue this part here. What you can do is mention that you want to continue the selected fault, the tracing of the selected fault. In that case, you can select this button here, or this check mark, add it here. You have to select the fault you want to continue, and then you can press this button again. So what will happen if you do this now is that you can see this red square. This red square, it tells you where the end of the trace is that you have traced. The bigger circle here tells you where you started. So if I now press this button again, you will see that this square is going away, and this is where we start essentially continuing our trace. Alright, let's see. You see the square disappeared, and now I can continue my trace. Alright. Good. And so I press space again. And I think I will just break this up into different videos and stop here for this one. Alright.